What if I told you that the entire AI industry has been betting on the wrong strategy? That hundreds of billions of dollars are being poured into an approach that one of the masterminds behind ChatGPT says is hitting a wall? Ilya Sutskever, the man who co-founded OpenAI, helped create GPT-4 and was at the center of the most dramatic boardroom battle in tech history, just broke his silence. And his message is shocking. The age of scaling is over. In a rare, explosive interview, Sutskever revealed why simply throwing more compute and data at AI models won't get us to AGI, why current models are brilliant on paper but fragile in reality, and why the next breakthrough won't come from who has the biggest supercomputer, but who has the smartest ideas. This is the future of AI, according to the man who helped build it. Let's dive in. Before we get into what Sutskever said, you need to understand who this man is, because when he speaks, the entire AI world listens. Sutskever isn't just another AI researcher, he's a legend. In 2012, he co-authored the AlexNet paper that kicked off the entire deep learning revolution. He was one of the founding members of OpenAI and served as their chief scientist for years, leading the development of GPT-3 and GPT-4. But then in November 2023, something extraordinary happened. Sutskever participated in the temporary removal of Sam Altman as OpenAI's CEO, a decision that sent shockwaves through Silicon Valley. Days later, the board reversed course, Altman returned, and Sutskever found himself sidelined. By May 2024, he had left OpenAI entirely, and he went silent. Until now. Sutskever has founded Safe Superintelligence, or SSI, a company that's already valued at a staggering $32 billion after raising $3 billion in funding. But unlike most AI startups, SSI has been operating in complete secrecy. Nobody knows what they're building. That's what makes this interview so important. After months of silence, Sutskever finally revealed his vision for AI's future, and it's not what the industry wants to hear. Here's the bombshell. Sutskever says the age of scaling is ending. From 2020 to 2025, the AI industry operated on one simple principle: bigger is better. More data, more compute, bigger models. It was a gold rush mentality. Whoever could afford the most GPUs would win the race to artificial general intelligence. And it worked for a while. We went from GPT-2 to GPT-3 to GPT-4. Each leap forward powered by exponentially more computing power and training data. The results were undeniable. The formula seemed foolproof. Scale up, and the model gets smarter. It was predictable, low risk, and companies loved it. But Sutskever says that era is now over. In his interview with Dorkesh Patel, he explained it clearly. Between 2020 and 2025, we were in the age of scaling. But now, we're entering, or rather returning, to the age of research. Here's his exact reasoning. Yes, if you multiplied today's AI systems by 100 times in scale, you'd see improvements. But would it be transformative? Would it solve the fundamental problems holding AI back? Sutskever doesn't think so. The issue isn't a lack of compute anymore. Companies are already spending billions building massive data centers and acquiring cutting-edge hardware. The bottleneck has shifted. What we're running out of isn't computing power, it's ideas. Think about that for a second. The entire AI industry has been doubling down on infrastructure, building bigger clusters, training larger models. But according to one of the field's greatest minds, that's not where the next breakthrough will come from. The next leap forward won't come from who has the most money to spend on chips. It'll come from who has the smartest research breakthroughs. Now, here's where things get really interesting and confusing. Sutskever pointed out something that's been bothering AI researchers for a while. There's a massive disconnect between how well these models perform on tests versus how useful they are in the real world. Look at the latest AI models. They ace incredibly difficult benchmarks. They score at PhD level on standardized tests. They can solve complex math problems, write sophisticated code, and pass bar exams. On paper, these systems look superhuman. But then you try to use them in real-world applications, and something weird happens. They stumble on simple tasks. They get stuck in bizarre error loops. Their economic impact has been far smaller than their test scores would predict. Sutskever calls this problem jaggedness, and he illustrated it with a perfect example, something he called vibe coding. Imagine you're working with an AI coding assistant. You run into a bug, you tell the model to fix it. The model responds, "Oh my God, you're so right. I see the bug. Let me fix that for you." And it does fix the bug, but in the process, it introduces a completely new bug. So you point out the new bug, and the model says, "Oh my God, how could I have done that? You're absolutely right." And then it brings back the original bug. You can literally alternate between the two bugs indefinitely. The model keeps apologizing, keeps understanding the problem, but can't actually solve it. How is that possible? How can a system be brilliant enough to understand complex algorithms, but not smart enough to avoid creating an infinite loop of errors? Sutskever admits, "We're not entirely sure, but it suggests something strange is going on under the hood." He suspects the problem has to do with how we train these models, particularly with reinforcement learning. RL training, he argues, makes models too single-minded, too narrowly focused on specific tasks and benchmarks. They optimize for the test, not for genuine understanding. It's like a student who memorizes every possible exam question but doesn't actually understand the subject. They'll ace the test, but they'll collapse when faced with a real-world problem that doesn't fit the exact pattern they studied. And that's exactly what we're seeing with AI models today. This brings us to perhaps the most fundamental insight from Sutskever's interview. AI models generalize far worse than humans do, and it's not even close. Think about how efficiently humans learn. A teenager learns to drive in about 10 hours of practice. 10 hours! And after that, they can drive on unfamiliar roads, in new cities, in different weather conditions. They generalize from limited experience to a wide range of scenarios. Now compare that to AI. To train an autonomous driving system, you need millions of miles of data, thousands of hours of footage, massive computational resources. And even then, the system can fail in edge cases that a human driver would handle instinctively. Why? What's the difference? Sutskever has a fascinating theory. Human emotions might be the secret ingredient. He referenced a medical case study about a man with severe brain damage that impaired his ability to feel emotions. According to reports, this man's decision-making became severely compromised. He would spend hours trying to decide which socks to wear. He made irrational financial decisions. Without emotional feedback, his reasoning collapsed. Sutskever's hypothesis is that emotions serve as a kind of built-in value function for humans, a biological compass that helps us evaluate decisions and learn from experiences quickly, even before we see the final outcome. When you're learning to drive and you cut a corner too sharply, you feel fear or discomfort. That immediate emotional feedback helps you adjust your behavior instantly without needing to crash first to learn the lesson. AI models don't have this. They only learn from explicit rewards, usually from whether they got the final answer right or wrong. They lack that intuitive, emotion-driven sense of "this feels wrong" that guides learning in real time. And this might be the key missing piece. If we want AI systems that learn as efficiently as humans, we might need to find a way to give them something analogous to emotions, a robust, biologically inspired value function that guides learning in real time. Now, let's talk about the elephant in the room: money. If Sutskever is right, if scaling has hit its limits, then the AI industry has a massive problem on their hands. According to some estimates, the tech industry has already invested close to $1 trillion in AI infrastructure, data centers, GPUs, specialized chips, massive compute clusters. Companies like Microsoft, Google, Meta, and Amazon are racing to build the biggest AI supercomputers ever created.
Mark Zuckerberg is reportedly paying some AI researchers $100 million per year. Per year! That's not a typo. One analyst calculated that for this level of investment to pay off, big tech needs to generate $2 trillion in AI revenue by 2030. $2 trillion. But if Sutskever is correct, if scaling won't deliver transformative AI capabilities, where's that revenue going to come from? This isn't just an academic debate. We're talking about potentially the largest misallocation of capital in the history of technology. Now, to be fair, Sutskever isn't saying that scaling is worthless. In a clarification on Twitter, he emphasized that current scaling technology will continue to deliver improvements. Progress won't stall completely, but something important will still be missing, something fundamental. And that missing piece won't be solved by
just adding more zeros to the compute budget. The industry needs new ideas, new paradigms, new fundamental breakthroughs in how AI systems learn and reason. And that's what Sutskever believes he's chasing at Safe Superintelligence. He says they're working on a completely new approach to AI development, one that focuses on research breakthroughs rather than brute force scaling. What exactly is that approach? He won't say. SSI remains secretive, and Sutskever made it clear in the interview that we now live in a world where you can't speak freely about such things. The competition is too intense. The stakes are too high. So when will we actually reach AGI, Artificial General Intelligence? Sutskever's answer is surprisingly specific, somewhere between 5 and 20 years. That's a wide range, but it's also remarkably soon in the grand scheme of things. We're not talking about a sci-fi future centuries away. We're talking about technology that could emerge within the next decade or two. But here's the critical caveat. It won't happen through scaling alone. The path to AGI, according to Sutskever, requires solving the generalization problem. We need AI systems that can learn continuously, like humans do, not just during a fixed training phase, but throughout their entire operational lifetime. Think about it. Humans don't stop learning when they turn 18. We continue to adapt, to acquire new skills, to refine our understanding based on new experiences. A real intelligent agent needs to do the same. Current AI models are trained once and then deployed. They're static, frozen in time. If the world changes, if they encounter situations outside their training distribution, they struggle. The next generation of AI will need to be fundamentally different. Systems that learn on the fly, that adapt to new contexts, that generalize from limited data the way humans do. And critically, these systems need to be safe. Sutskever emphasized that AI safety isn't something you bolt on at the end. It needs to be baked into the training methodology from day one. The way we train models determines whether they'll be reliable and aligned with human values when they encounter unknown situations. This is why he founded Safe Superintelligence. The name says it all. The goal isn't just to build superintelligence, it's to build it safely. And according to Sutskever, that requires rethinking everything about how we approach AI development. So where does this leave us? The AI industry is at a crossroads. For the past 5 years, success was defined by scale. Who could build the biggest models? Who could afford the most compute? But according to one of the field's founding fathers, that era is ending. The future of AI won't be determined by who has the deepest pockets. It'll be determined by who has the smartest ideas, who can solve the generalization problem, who can build systems that learn like humans, efficiently, continuously, and safely. Sutskever's message is both a warning and a challenge, a warning to the industry that scaling alone won't deliver AGI, and a challenge to researchers to return to what made AI great in the first place, fundamental breakthroughs driven by creative thinking and scientific insight. The race to artificial general intelligence isn't over, but the rules of the game are changing. And the companies that recognize this shift early, that invest in research rather than just raw compute might be the ones that ultimately win. If you found this analysis valuable, make sure to like and subscribe. This is one of the most important conversations happening in AI right now, and we'll be covering every major development as the story unfolds. Thanks for watching. I'll see you in the next one. Subscribe for more AI insights.